All right, yesterday we talked about 5.08, the product rule, and then the next lesson would be the quotient rule of derivatives, right? We got quotient rule of a lot of things in math, but this is our quotient rule for finding the derivative. So if you look at just kind of a simple problem, all right, or our parent function, this is going to be when we have some function divided by another function. When you see a fraction or you see division of two functions, you should be thinking quotient rule, quotient the result of division. So in order to find your derivative of two different functions here, here's what you're going to do. It's just like the product rule, u prime v. This time we're going to minus uv prime, and we're going to put that whole thing over v squared. All right, so if we actually want to take the derivative of this, it's not so easy as just taking the derivative of the top and bottom and dividing them. We actually have to take the derivative of the top and bottom and put all of these things in this crazy order that looks like this. There's my quotient rule. All right, so let's take a look at one of these in practice, and let's try to do our best to simplify them. I'm going to start with a relatively simple one, simple-ish. 4x plus 1 over, let's say, 2x minus 5. Okay, here we can see that we have a function on top. We have a function on bottom. Yes, I'm going to have to take the derivative of each of those, but how I put those together again is really important. And then, of course, we're going to try to simplify it. So u, I'm just going to annotate, is the top. V is the bottom. So let's see, u is going to be 4x plus 1. V is 2x minus 5. Now I'm going to use my power rule here. Well, 4x, remember, just turns into a 4. It turns into a constant, right? Because that exponent of 1 turns into an exponent of 0. It essentially disappears. 1 turns into just straight up 0, so that disappears completely. So 4x plus 1 turns into 4. 2x minus 5, by the same reasoning, just turns into 2. So now we have our derivatives, and now it's a matter of putting these derivatives in the correct order. Let's move over to the side here. I know this is kind of disorganized in the way that I'm attacking this problem. So that means y prime is going to be put in this order. What's u prime? Let's see, that's going to be 4. I'm going to put that in parentheses. What's v? It's going to be 2x minus 5. I'm going to put that in parentheses to make sure that I know I'm multiplying the entire thing. Minus, what's u? 4x plus 1. Multiply that times 2. And this whole thing is all going to be over v squared, which is at 2x minus 5 squared. Notice my use of parentheses. I know my work is kind of sloppy. I'm writing on my computer. You can do better in your notebook. Now, technically, this is the answer, right? This is it. This is our function. But that is definitely not simplified. And you won't see an answer like that on a test. You will see an answer like this simplified and boiled down and condensed into a much, much prettier looking version of this function. So while this is the derivative, it's just not going to be your final answer most of the time. So what would I do to get that final answer? I'm just going to go ahead here and distribute, right? There's one term times 2. So there's no need to set up the box method or FOIL. I'm just going to distribute. And then here, even though there's one term at the back, I can just kind of distribute from the back here. So what am I going to get? Let's see. I've got y prime equals, let's see, 4 times 2x is 8x. 4 times negative 5 is negative 20. I'm going to keep that in parentheses and keep that minus sign. And I'm going to do 2 times 4x, which is 8x, and then 2 times 1, which is plus 2. And I'm going to keep that inside parentheses. And then everything that I haven't worked with, I'm still going to keep inside parentheses. This is better, but it's still not condensed or simplified enough, because now that I've done my multiplication here, these two things on top are not being multiplied. They're actually being subtracted. So just remember that when I'm subtracting, what I need to do when I have parentheses is I actually need to subtract both these things. Think about distributing that negative to the inside. So now we have an 8x minus 20 minus 8x minus 2 all over that 2x minus 5 squared. All right, I'm running out of room, so I'm going to finish this over off to the right here. I'm going to combine like terms on top. So what's an 8x and a negative 8x? Well, that's 0. What's a negative 20 and a negative 22? That's negative 2 is negative 22. So if I was being asked to find the derivative function here, if I was given y and I needed y prime would be this. In as simple a form as I can make it, it's negative 22 over 2x minus 5 squared. There's nothing else I could simplify. You can actually try to expand the bottom, but you would just be creating more work from yourself. We're trying to get rid of things, not really add so many things together in this case, because nothing will factor out of the top there. That's my answer. So let's talk about some really kind of important things before we kind of go try these. This formula, super important, right? Once I identify U and V, it's a matter of finding those derivatives, U prime, V prime, and putting those things in the correct order according to the formula. I could distribute in this problem. I could simplify. If I ever have that opportunity, I'm going to give it a try. And here is my final simplified answer, which is the same as this answer right here. These two things are the same. It's just that this last one is simplified, and that's what we prefer. Go ahead and try this quotient rule on your own for two functions that are being divided when we need the derivative.